So what we're going to learn today is an addition to what we went over in the last tutorial video. So last time we made a basic model of our spinning top with all of the requirements and things that we can do with the appropriate dimensions and processes and everything like that as well. Okay, so this time we're going to extend on that. So our learning intentions are to use our original design, so our iteration 1, to adapt and make a new design. So this will become our MK2. Now, this isn't the only way that you can reiterate. You can start from scratch as well because it's not a very hard thing to model. We're going to use some slightly advanced modeling techniques, and I'll detail those in the next slide. We're going to make an engineering drawing, and we're going to annotate that engineering drawing as well. And all of these are requirements in your assignment. So when I finally put up samples, you'll see A, B, C samples, and you'll know exactly what I mean. Okay, so the tools that we're going to be using today, we're going to edit our sketches, and I want this to be a common practice for you. Rather than making new sketches, whenever you want to make something new, you need to be able to differentiate when you should make a new sketch and when you should edit an existing one. We're going to make an angled plane to make an angled hole into our spinning top, and we're going to use the push-pull command to make some adjustments to our model once it's made. Okay, so the processes we're going to go through: create an engineering drawing, annotate dimensions, and annotate text. The purpose of your engineering drawing is to create your hypothesis. So before you've actually tested and printed your design, you need to create a hypothesis using appropriate language that we're covering now before you test. After you test it, you do an evaluation of how it went based on your data and based on the characteristics of that test. So whether it wobbled, whether it stopped really quickly, whether it did really well, and always with evaluation how you could improve and add value to what you've already done. Okay? So your success criteria, your spinning top will have one aspect change to create a valid test. So for your iteration 2, pick one thing to change. That could be the position of your weights. It could be the shape of your tip. It could be the center of gravity. It's up to you. I also want you to experiment with angled weight holes as well. So they'll be placed at an angle. That's another criteria for success. And you'll also have an engineering drawing annotated with dimensions and text as well. So let's get into it. Oh, that's me. I want to go to Fusion. There we go. Let's make sure it's recording properly. Good. Okay, so this is the existing spinning top from before that I demonstrated to you. I'm going to turn my grid back on. So first up, I might change the position of my weight holes and maybe do some minor adjustments to the form that I've made. Okay. I know that I'm making 2 adjustments, but I want to show you how easily you can do that. Okay. So if I want to change the basic form of my spinning top, I would go back to this sketch and edit. Okay. You actually can also change drawings without going into edit mode if you make them visible. But what I'm going to do here is try and make some changes. So I can grab this, push this around. I can grab this anchor point, pull it in. This is without me even pressing the sketch tool, yeah? Okay. So you can push around your model to change its form. And then as soon as I do that and go finish sketch, the form will be fundamentally changed. So everything will regenerate. It might take a little bit of time to do that. Okay, so that's made that fundamental change. Everything is tried to regenerate, even the text that I've put in before. It looks a bit messy, but it's done its best job to reproduce what I had before. This is parametric design. So when you make changes, the software adapts for you. Okay, so this is how Fusion 360 is different from other platforms like Blender. Okay, it's parametric, it's specifically for design, and it's there to aid the designer in making iterations really quickly and easily. So I'm not particularly happy with that, so I might go back and change that again. So I'll go edit sketch, or you can just go Control Z. What I might do here is I might select some line segments. So I want to make this shorter, but I can't pull this down because it's constrained to this top axis here, to this top part of my construction box. So what I'm going to do here is draw a new line a bit lower and then delete the lines that I don't want using the snipping tool, okay? So this one, I might delete that. I'm going to click snipping tool and just click on that one. It'll remove the line completely, and you'll notice that it's gone from a shaded blue shape to no shading at all because it's an open shape. So what I can do here is redraw this line. I can pull this one out. I can make a slightly easier curve with my line tool, and then I can link these two together. All right, I'm pretty happy with that. The other thing I'll do here is just cut this off. So I'll draw directly across to here. And then from there, as soon as I draw that line, it'll segment these other lines. So notice how I can select individual parts of this line. I'm going to go there. If you select the wrong one, that's fine. If you have a line on a construction line, sometimes it picks up the construction line instead of the solid line that you've drawn. That's okay, you can just go Control Z. All right, I'm fairly happy with that. I've changed the form, and I'll go Finish Sketch, and that will regenerate as well. Other things that you can do, I'll demonstrate for you directly in a second. Okay, that's looking a little bit nicer. I might need to change the position of the sketch of my initials and things like that to make it all work a bit better. So other changes that you can make. You could go in and change the shape of the tip that you've designed. Okay, so you might want to go from here and try and make a rounded tip. This curve, I want to go down and around. So maybe using the line tool isn't the right thing to do. I'll just go Control Z. I'll use a spline tool. I'll go from here. And the spline tool is always curved, but it will kind of equalize a curvature between points. So I'll go down to here and then down to here. And I'll go on green tick to indicate that I want that line chain to stop. Okay, and you'll notice how that's slightly curved. After you've done that, you can actually manipulate these handles here to change the curvature of that line. You can also move the points around. Again, change the curvature of that line. If you click on a point like that, the handles will appear and you can change it around. Yeah? There's a relationship between all of those points on this little line chain here. Okay? And if you make a mistake, Control Z, go back, and those changes will go back to the way they originally were. So I'll finish that sketch. And you can see that that's reflected in the changes that I've made. Okay. I'm doing all of the changes in one model so you can understand what your options are. So far, I've changed the center of mass, okay, by increasing the volume of the form. I've also changed the tip, so the way the tip interacts with the testing surface, the friction might behave a little bit differently, so something to test there as well. The other thing I can do here is again through editing sketches. So if I go back to my sketch of the weight holes, I can also grab this and pull that in. And all I need to do is go Finish Sketch, and all of those weight holes are regenerated. Okay, so it'll put it back through my pattern repeat and do everything for me. If I need to replace where my text is, I just grab these and do my best to move them out. Sometimes they may not want to work for you. So I might right click and see if I can move. All right, seems to be working for me a little bit. It might be constrained though. Okay. So it's constrained with another sketch. There we go. Because I did edit text on a path, I had to redefine that path. Now I can just go OK and finish sketch, and everything again should regenerate. Now you'll notice here there's a feature. What did I do here? I did a push-pull. All right, this was applied to something else. It might have been the weight holes or something like that. I can't quite remember. But if you want to do simple changes to your spinning top, remember you have to stay within your dimensions, but you can select the push-pull command and just grab this and change that around to what you want, okay? You can also do that to cylindrical surfaces as well. So you can grab this and go to push-pull, and you can try and inch this in as well, and that will fundamentally change your form. Okay. You can also group surfaces together. If I want this to also, when I hit Control, it'll go back to its original. If I want to include this surface in that push-pull command, I can just Control and click that, and it'll try to include that surface into the push-pull command. If it gives you an error, then just hold down Control and deselect it. Okay. It might work on this one. There you go. So see how it's regenerated that curve? These are smart functions that are only present in parametric design software. Okay, so I don't mind those two little changes I've made, and you'll see that this compared to my original, what I'll do here is I'll go File, Save As, like you do with a new document, and this will be green spinning top MK2, and I'll save that. All right, that's all saved and done. So what I get to move on to now is my engineering drawing. Okay, I'll do that quickly. This is really important though, and you do have to practice this. It's a new process. So with your design open, go to Design, Drawing, From Design. And you'll come up with this panel over here. So going down, you only really need to make an A4 design sketch, and I would make it in landscape orientation. So go to sheet size. You can make custom sheet size, but just go A4 and make orientation like that. You'll be going create new drawing from scratch. ISO is the standard of drawing that we use in Australia. After you've checked through that, just go OK, and it'll open up a new window for you. And the first thing you do when you open up that window is you will lay a base view. Okay, so this is our A4 sheet. Alex, wake up. This is our A4 sheet, and we're going to lay our front view here. Now, do I have to lay 3 views, a top, front, and side view? Who knows? Would I do a top, front, and side view, or would I just do 2 of those?
Top, front, and side.
Why would I do top and front, or top and side? They're the same thing. Why? Because it's a cylindrical object. Okay? Thanks, Axel. So I'm going to lay that one down there. You'll have 2 main drawings, and then you'll have an isometric perspective as well. Okay? You can change the perspective here, and you can also change whether it's top or front in this menu here as well. You can also change how the plan is depicted, right? So this will be just vectors and lines that you can see. This will be all vectors and lines you can see. This will be all lines you can see and also shaded. This will be all the lines in the model and also shaded. Okay, so you can check those 4 different types there. All right, so what I'm going to do here is just start with visible edges. I'm going to go to front, and I'm going to click OK. When that's locked in, it'll just turn to vectors. And we use this same technique to run our laser cutter, which we'll be doing in the next unit. Now, I want to put in the rest of my views. I've got this here. I also want to, now looking at it, I want to put in my weight holes as well. So I'll go back and change this to visible and hidden edges. And I've just realized I haven't showed you how to do an angled hole. But that's okay, I can do this first. Okay, so there's my weight holes there. Now, I want to make a projected view from here. So what I'll do is play a base view. You can orient that any way you want. You select base view and you put whatever you want down, okay? To make a projected view, you work off a drawing that's already down. So here, project, and then you move that down. Now, if I move this off to the side, it'll do a side view. If I move it down, it'll do an isometric view. It'll do that automatically for you, okay? I'm going to lay that down here and go green tick, OK. All right. You can also move these around, but because they're projected views, they're linked. So I might put these over here, and then my annotations will go around this area. Also, if I'm not happy with the orientation, it is a ratio, 1 to 2, okay? Or I can do 1 to 1.5. Okay, so you can use decimals in that ratio as well. So I'll make it 1 to 1.5. Then finally, what I'm going to do is an auxiliary view, another projected view, and I'm going to go down to my isometric mode here. Now, this isn't linked explicitly to these two, so I can actually change the dimensions of this independently, and I can also change how it looks independently as well. Okay, I can also move it independently without it being linked, okay? So that's what I want your engineering drawings to look like, okay? Now, we've spaced everything out. Now what I want you to do is to annotate. Okay, so the last thing in our engineering drawings, I'll show you quickly, because I can tell people are getting a little bit bored. So I'll go annotation. I'll click on the annotation menu, and then when you're in this annotation menu, you can go linear dimension, diameter dimension, radius dimension, angular dimension. You can also add a note, which is what we'll do to annotate the text of our design, okay? So we'll go back through some of the hypotheses that we discussed before. So linear dimension, I might want to go to this width again, even though it's the same as before. So I'll right-click again. You can go repeat linear dimension, or you can go to annotation menu and choose a different thing to annotate. Okay. For radius dimension, I might put that down here or on the outside. So what does the R mean? Radius. Yeah. Radius 29.73. So that's half of the diameter. All right. I might want to measure this angle as well. So we'll go annotation. Where's angular? Angular dimension. I'll go here. Okay, and we've got that angular dimension there. Okay. Now, we might want to annotate certain features of our design as well. So we'll go right-click as well, annotation, note, and then we'll attach our note to a specific feature. Usually it's a line. So we'll go here, and then we get to place out where we want that text. So instead of picking a point value, you'll change the size of your text through how high it is in millimeters. I'll go 2.5. Okay. And the thing that I'm annotating here if your text is getting too long, just press enter and it'll start a new line, kind of like an old typewriter. So weight holes are placed close to the axis of rotation. And so in this case, I'll be experimenting with inertia and whether it's better to put weight holes towards the outside or towards the inside. Okay, so I want to try and set myself up so I'm changing one thing. I know I've made 3 changes here to demonstrate to you what you can do, but your next iteration might just be a simple changing of where you place your holes. If there's an obvious inefficiency or something that doesn't work, then you might want to make a more drastic change and also, change where your weight holes are as well. Okay, after you've done that, Press OK, and that will be annotated there. What I expect to see is a few annotations of your design features and any changes that you're about to experiment with. After this, you would publish your data, and after that, you would publish an evaluation of your performance characteristics and things like that. Then after that, you rinse and repeat. Model again, engineering drawing again, evaluate again, continue to make changes. The faster you can get through that process of iteration, the more chances you have of successfully creating a really high-performing spinning top. Okay? So the last thing I'll show you, and I'll show you how it relates to the drawing as well, is I want to create an angled hole. So what I'll do here is I'll actually delete or suppress this whole feature here, okay? So I'll suppress that, that sketch, and what it'll do is it'll eliminate everything relating to it, okay? The other thing, I can unsuppress it, and I can also go to right-click and delete, okay? If I want to make an angled hole, what you would want to do is make them point out at something like this angle, okay? But you also need to be conscious of how you're going to put them in with that stem in that position. So maybe more of an angle like this, something you might want to experiment with. You might want to experiment with a shallow angle going in more towards the center. Some people have even experimented with laying them flat in the top of their design too. But also it needs to function properly, so the weights just can't fly out as soon as you start spinning it up. So don't push that too hard. So what I'm going to do here is I'm going to draw onto this top plane, and I'm going to actually project a hole into my spinning top. So I'm going to go here, and all I'm going to do is make a straight line. So I'm going to go to here. I'm going to draw a straight line directly across and go finish sketch. That's all you need. Oops, that hasn't worked out the way I wanted it to. So straight line like that. Because I moved it off the orientation of the plane, it didn't attach properly. So I'll go finish sketch. Okay? So I should have a line just floating in space. Now what you do is you select that line, and up here, plane angle. It's also here under the construct menu. Okay? So plane at angle. And then what you can do is you can change that angle of that sketch plane, and you can actually eyeball it to place it to a point where you think it'll fit properly. Okay? So after I've got that angled plane, I'm going to get rid of that sketch, so I'll just make it invisible. You can see the eyeball there. And I'll go here, and I'll go sketch. And so where I put this circle for my weight holes, it'll go directly into my model there. So I'm going to go circle, center diameter circle, place it on that axis. 6 millimeters should do it. I'm going to go finish sketch. I'm going to take that sketch and I'm going to go extrude and extrude that in. Now, as soon as it hits the surface, it's going to turn into a cut. Here, it's a join function or a new body. As soon as it hits here, it's going to cut. Now, what I want you to do, because the weights are 15 millimeters long, is count for the better part of 15 millimeters into your model. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, I might go 12. Okay, just so I have a little bit of the weight popping up. And I'll go, okay. Then I go through the same process. Take this feature, create pattern, circular pattern. Objects I've already selected. Axis is here. You can choose the stem or the central blue axis there. It doesn't matter. And I'll repeat that 6 times. Okay. Easy peasy. Cut right through my initials, whatever. If I had the time, I'd change that later on. Now, if you make that change after you've done your drawing, it's okay. First thing you need to do is save it. So that'll go from MK2 V1 to MK2 V2. And then if you go back to your engineering drawing, it'll give you a little warning here saying changes have been made to a reference design. You can update the drawing from the button in the application bar. And that is right here. Okay, so if I hit update, that's updated the weight holes that I've distributed before. Okay. Now, really advanced models can actually, it works both ways. So you can actually change your design dimensions in your sketch and they'll go back to your original model as well. So I could, for example, I think I could go here and change 10 to 12. I think. I'm going to look really stupid if this doesn't work. No, I won't do that right now. So that's how you can make changes. So I want more annotations than this. So the diameter of your holes, the angle that those holes are going into your model, anything else you can think of to annotate that is from the perspective of the designer designing something before it is tested. So you need to take the perspective of what your expectations are for this design, what you're actually testing, okay? Be really, really clear about that. All right. So that is pretty much the tutorial. So yeah, don't forget your success criteria. And thank you very much for watching. I'll have this up on YouTube soon.